Welcome, my name is Vishal Sharma. This project aims to build an embedded system which acts as a proximity sensing system by changing LED brightness accordingly using PWM. Let us first understand PWM. Pulse width modulation is used to generate an analog signal through a digital source. PWM simulates varying voltages by changing the width of the digital power output, that is, by changing the duty cycle with a constant frequency. The duty cycle of the PWM wave is the primary property we will be using in this project. Duty cycle is defined as the percentage of time in 1 unit period of the wave signal for which PWM on signal or high voltage is transmitted. As in high frequencies, the changing states from high to low are not observable, but the duty cycle which dictates the time for which high signal is given relative to each period becomes the factor which dictates the average voltage of the signal. For example, if the input voltage is 10 volts and the duty cycle is 50%, the output voltage will become 5 volts. Therefore, you can change the brightness of an LED by simply changing the duty cycle of the PWM signal. This is the primary concept behind this project. Now let's look at the details of the system. The hardware required is as follows. A Raspberry Pi board. I'm using a Raspberry Pi 4 Model B board for this particular project, an HCSR04 ultrasonic sensor, resistors, LED, and some jumper wires. The system is used for proximity sensing. The trigger pin of the ultrasonic sensor will send a short ultrasonic pulse. The echo pin will receive the pulse after it bounces back from the surface closest to the sensor. The time between sending and receiving the pulse will be used to calculate the distance from the object. Now the duty cycle of the PWM signal to the LED will be controlled by the distance calculated. This is the circuit for this project. Now let us look at the code for this project. We have our initial setup, including importing libraries and setting the GPIO pins. And in addition to that, a PWM instance is also created. A function named ultrasonic is defined to compute and return the distance observed by the ultrasonic sensor. A function named PWM which takes in the distance as the input and changes the duty cycle of the LED accordingly. The libraries used are RPi.gpio and time. GPIO is set to GPIO.board pin mode. In addition to the trigger pin which is set to output mode, an echo pin which is set to input mode, a third pin namely PWM is defined to which the LED is connected. An instance of the PWM class which is part of the RPi.gpio library is created using the PWM pin defined earlier. To create an instance of the PWM class, we use the GPIO.pwm method which takes in two inputs. First one is channel, which in this case is our GPIO pin, and the other is the frequency of the signal. To initialize the PWM instance, we use the pwm.start method. This method takes in DC, that is the initial duty cycle as the input, which can be arbitrary. To change the duty cycle, we use pwm.changeDutyCycle method, which takes in the new duty cycle as input. Since duty cycle is a simple percentage, the constraint for its values are between 0 and 100. Now let us look at our function named ultrasonic. The trigger pin's value is set to true, that is voltage is set to high for 10 microseconds. This is done to shoot out an ultrasonic wave. When the ultrasonic trigger pin sends the wave, the echo pin's voltage is set to high by the ultrasonic sensor. The variable start time calculates the instance when the echo pin's voltage is set to high or when the wave is sent. The variable stop time calculates the instance when the echo pin receives the wave, as at that particular moment the voltage of the echo pin becomes low. The variable duration time calculates the difference between sending and receiving the wave. Since we only need to calculate the distance from the object, we need to concern ourselves with half of the duration time rather than the full round trip of the wave. Now, we multiply this half duration time with the speed of sound, we get the distance from the object, and the same is returned by the function. Moving on, a function named PWM is created. It takes in the distance from the object as an input or argument. The function changes the duty cycle of the LED only when the object is at a maximum range of 20 cm. Duty cycle is inversely proportional to the distance of the object. This whole program runs with a simple infinite while loop, which checks the distance from the object and updates the duty cycle every 100 milliseconds. Now let us look at a demo for this project. I hope this video helped. Thank you.